In order to combine like radicals, we need to first know what like radicals are, and it's basically like terms. Like radicals are going to be the terms that have the same radicand and the same index, so the same number under the radical and the same number outside the radical. In order to combine them, all we do is add the coefficients. So if we have the cubed root of 5 plus 8 times the cubed root of 5, the coefficient of the first one is just a 1, and then the coefficient of the next one is 8. So this is saying we have 1 cubed root of 5 and 8 more cubed root of 5s, so altogether we'll have 9 cubed root of 5s. And that's all we have to do to combine like terms. Sometimes these radicals don't look alike, and we need to simplify the radical first. So this cubed root of 54, we have to look at that as 27 times 2. Because the cubed root of 27 is a perfect cube. Well, the cubed root of 27 is 3, so we'll have 3 cubed root of 2's minus 1 cubed root of 2 leaves us with 2 cubed root of 2's. We'll even have to do it with fractions. So altogether we have a 5th square root of w and 3/5 square root of w's. So altogether that's 4/5 square root of w's. Now remember, when we have rational exponents, those are really radicals. But this kind of goes back to combining like terms again, because when it comes to terms are going to be, they'll be alike if you have the same variable raised to the same power. And for both of these terms, we have x times y to the 1/4. So I have 3xy to the 4th minus 8xy to the 4th leaves us with negative 5xy to the 4th. Notice that we don't do anything with the x's or with the y to the 4th. They all stay the same. Just like in every other example, what was under the radical stayed the same. We didn't mess with that at all. We're just saying how many of them we have. So even here, when we have 8 to the 1/5, remember 8 to the 1/5 is the 5th root of 8. And I got 10 more 5th root of 8's. So when we combine them all together, there's 12 of the 5th root of 8's. We don't mess with that 8 at all. We just leave it alone. And so our solution just tells us how many of the roots we have.